Good morning, everybody. We're going to spend a little bit more time talking about weather and the science of weather. And we had said that warm air holds more moisture, more water molecules, tiny ones floating around, and cold air held less water molecules. Cold air has a tendency to have the water molecules come together and fall out, where warm air supports the water molecules floating around. A part of this, and a big part of weather, is air pressure. Air pressure is the pressing of air all around you all the time, on your face, everywhere. Air is pressing down. It's gravity pulling the air against the surface of the earth. And the closer down to the earth you get, the more air you have pressing down on top of you from just gravity. And the higher up you go, you have less. I'm going to get out of the way to show you a little diagram here. So you see this little scientific diagram as a blue column of air in the middle. Well, I mean, the air is happening all around. Do you see the little white dots in it? Those are supposed to represent air molecules. You know, it's not true to size. But as you see, air pressure, the definition is the weight of air in the column above you. So the closer down to the earth you get, the more air molecules you have pressing down on you, higher air pressure. The higher up you go, the more the molecules have less molecules sitting on top of them and they're more spaced out, less air pressure. But more importantly, let's start with the definition. The definition of air pressure is the weight of the air in the column above you. Air pressure is the weight of all the air in the column above you coming down. So I just wanted to get that written out too. What is the scientific definition of air pressure? The weight of the column of air above you. If you go higher up like a mountain or in a balloon, why is the air pressure lower? There is less air above your head to make the weight of pressure. Is this beginning a sense? Can you visualize this? A column of air, air pressure. Air pressure has everything to do with weather and the science of weather. One of the major things is air pressure, air density. More dense air, the bigger the pressure. Less dense the air, the less pressure. And it has to do with hot and warm and water being in the air. It's a lot of variables. The whole thing of air pressure is really super interesting. People have been studying it for a while, too. This image right here is a very interesting experiment done in Germany in the 1600s. I'm going to get me out of the way here. And what he did is, I don't know if you can see those orbs up top that say A and B. They were put together and then he pumped the air out of them. So in those little orbs that are fit together, there's no air. And as you can see, he put a whole bunch of weights attached to it. And what he saw that was when you had two spheres with no air in them, they wouldn't come apart, even with lots and lots and lots of weight, because of all the air pressure around the globes. Now, for a long time, they got confused. They thought it was something inside the globes keeping the globes together when there was no air inside that big circle that says A and B. It's actually all the air surrounding it, kind of pressing on it and keeping it closed. Kind of cool, huh? So you see right there, right? The air globes that they're in a vacuum, which is why they're stuck together. So what we learned before, too, is with air density, cold air is heavier and has a tendency to fall down because Well, they move less. Cold air, it's cold because the molecules aren't moving as quickly. So they pack into more of a space together. Cold air is more dense and has a tendency to fall down to Earth. Warm air has a tendency to rise because the air molecules are moving faster and are taking up less space and are less dense. They're lighter. So one of the basics of air pressure that you've got to understand is that cold air has a tendency to fall. It's heavier, more dense. Warm air has a tendency to rise. It's less dense. It's lighter. And that's because literally the warmth is just the energy of all the air molecules moving around. And they take up less space. So, warm air has a tendency to move which way? Warm air has faster moving air molecules, so is less dense. Because it is less dense, it rises. Cold air has a tendency to move which way? Cold air has slower moving air molecules, so is more dense. Because it is more dense, it has a tendency to fall. So dense means packed together, heavy. Next question, we're going to look at a diagram. Wrong one, sorry. Ooh, right one, good one. Okay, let's bring it in. So this is actually from a YouTube video. Here, let me get me out of the way here. And I'm going to put the video link on the worksheet. But look at that, isn't that cool? It's cold air moving into a front of warm air. See the labels cold air, warm air? And the front is where the cold air meets the warm air. Now look what happens right there at where the cold front meets the warm front. Do you see it? Do you see it right there? Right there at the end of my finger. Where the cold front meets the warm front, you see those columns of clouds that form? They call them cumulonimbus. They tend to be rain clouds. So when a cold front meets a warm front, it has a tendency to push the air molecules out of the warm air into raindrops. So, what usually forms when a cold front meets a warm front? Check out the question right up there. What usually forms when a cold front meets a warm front? The cold air makes the moisture in the warm front condense into rain. So there's usually rain clouds on the edge of a cold front. Remember that picture? Now let's do the opposite. What happens when a warm front meets a cold front? Well, the answer is, and I'm going to show a picture, the warm air glides over the more dense cold air. It kind of pushes it in this longer wedge shape because the cold air stays on the ground. It's heavier. And then thinner clouds tend to appear when a warm front meets a cold front. I'm going to show you a picture. Now, weather gets complex because also when warm air comes, it tends to rise and can meet cold air up and make more rain happen. Weather is complex. But for our worksheet, we're going to keep it what happens when a warm air glides over a cold front. Let's show you a picture. Hold on. Whoa. I lost it. Hold on. Where'd it go? It's here. Hold on a second. Learn about my... Yep. I have it. select it. Here we go. I gotta grab it. Ugh. Okay, come on. We're having some technical difficulties here. Try to select it again, see if that happens. Trying to get my picture, but I put it out of the way. Let's see if we can do with a different one. There we go. I think I grabbed it. Okay. Now that I moved it back, I can change it. Learning my streaming software here. Okay, let's go back to the pictures. Yay, we did it. Okay. Look at that. When a warm front meets a cold front, do you see how the shape is different? The cool air hugs the ground and has a tendency to be pushed into a long shape by the warm front. So thin clouds have a tendency to form above when a warm front meets a cold front. Now, it doesn't get confusing. We said cold front, warm front so many times. But our first example was when a cold front moves into warm air. And now this one is when a warm front moves into cold air. Let's go back to the last question. See, and this is where it got pushed up. I went up to the top. What kind of clouds tend to form when a warm front meets a cold front? The warm air glides over the more dense cold air, pushing it into a longer wedge shape. Thinner clouds tend to form over the edge of a warm front meeting a cold front. So, ladies and gentlemen, this is your video for which you to work on this worksheet. I want you to use this video to get me the answers to the warm front, cold front question. And remember your density. All right, we'll talk about this in class, and we're starting to study the complexity of weather.